We are at Chapter 10. In Chapter 10, we're going to learn about the Lewis model. This is the first of two chapters about chemical bonding. The quote for this one is by Karl Popper. "Theories are nets cast to catch what we call the world. To rationalize, to explain, and to master it, we endeavor to make the mesh ever finer and finer." So we are going to be looking at three different bonding models. And why are bonding models important? This here is an example of how a bonding model is useful. So in 1989, they determined the structure of HIV protease, which is an enzyme synthesized by HIV. And after determining the structure of that, researchers were able to use bonding models to develop several different molecules that would block the active site of that enzyme, essentially shutting it down. And they could do this because they could predict the shapes of molecules and how they would interact with the active site of this enzyme. So instead of a trial and error, which can take a really, really long time, they were able to do this more quickly. So those protease inhibitors don't cure HIV, but they cut it down to undetectable levels, which is almost as good, right? So bonding models are useful for that. The one model we're talking about in this chapter is called the Lewis model, and it uses dots to represent the valence electrons. And so we'll be drawing Lewis dot structures or Lewis electron dot structures as little pictures of molecules. It's very simplistic. It's great for quick predictions about a lot of molecules. Doesn't work for everything, of course. But it's really great for predicting the shape of a lot of different molecules, and we can also use it to predict if a molecule is going to be stable or not. Yeah, I thought I missed something. I accidentally skipped this page. So bonding theories explain how the atoms stick together, how they make bonds to form molecules. And the shapes are very useful in terms of predicting chemical and physical properties. There are several different bonding models. They vary in complexity. So the Lewis model is one of the simplest. So it's the easiest to understand, but it also is the most limited in its predictive properties. And then we'll look at valence bond theory, which is more complicated, but also applies in more situations. And then we'll just peek at molecular orbital theory, which is very complicated, but it does apply to almost everything. The good thing is we don't need to go into that much complexity for general chemistry purposes. So that's good.